We just finished our previous section on getting an LED circuit using a potentiometer to control the brightness of the LED. Now we're going to go over how you can actually toggle the LED to turn it on and off via software on the Arduino. So before, in the first part, we connected the LED straight up to the 5-volt pin, which means that it's always going to be on when there's enough current to power the LED. Now we're actually going to use something called digital write in the Arduino library, which will help us toggle the LED on and off. So to build this circuit, to be very similar to the circuit from part 1. It's just that the power is going to come from a digital pin. So we'll build that circuit now. Take our 1K ohm resistors, plug it into any of the digital pins. So I'll connect it to digital 3 here. It doesn't matter, any of the digital pins should work. Then we'll take one of our LEDs, connect the positive lead to the output of that resistor, the negative lead to another row, and then finally we'll take a jumper from that negative lead on the LED and plug it into ground over here. All right, there we go. That's all there is to it. Now we'll go over the software. All right, hello everyone. So we just finished our circuit that we can control an LED via code. Now we actually got to write that code. So here you can see that I've opened a new Arduino sketch. So it has the default, name here. I haven't saved it or anything like that. I haven't written anything yet. So when you open it up, you'll always be confronted with two functions. These will be empty. One will be setup and one will be loop. So the setup function is one that is run exactly once, and that is run when the Arduino receives power for the first time. So if you want something to run once and never again, you should write it in your setup function. The loop function, on the other hand, runs forever, over and over and over and over again. The first time it runs is after setup, it completes once, and then from then on, it'll repeat to infinity or until the Arduino loses power. So in order to turn our LED on and off, we first need to initialize our pin that it's connected to be an output pin. So on the breadboard, we connected the LED to digital pin 3. That means that we need to initialize pin 3 to be an output pin. We only need to do this once, so we're going to be writing this in our setup function. So within setup, we're going to write pin mode. Be careful on the capitalization. When you type it in correctly, it should turn orange. So this is a built-in function into the Arduino environment. You don't need to include any extra libraries or anything like that. You just need to type pin mode and it should work. So pin mode. Pin mode takes two arguments. So the first one is the pin that it's connected to, and the second one is what mode we want to send that pin to. We connected on our circuit pin 3, so we're going to write 3, comma, output, and then write our semicolon. This means that we're going to be setting pin 3, so digital pin 3, to an output pin, which means it can either send out 5 volts or nothing, and then the LED will eventually be pulled to ground. Now within loop, we need to actually make it blink now that we've said that we can use the pin as an output. To make it blink, we need to use another function called digital write. So digital write also takes two arguments. The first one is the pin, so 3, and then what we want to write. So in our case, we want to write high. In order to turn the LED on, we need to set the output voltage to be 5. Now we've written high. But in order to make it blink, we need some situation where it can turn off. And if we were to write simply digital write 3, low to turn it off immediately afterward, like here, the problem is it'll blink so fast that we can't even tell because the clock speed of the Arduino is significantly faster than the human eye can detect. The clock speed is around 16 megahertz, and even though digital write might take multiple cycles to complete, it's still going to be significantly faster than the human eye can detect. So to allow us to see that the LED is actually blinking, we're going to write delay function in between. So delay is another function that's built right into Arduino and takes an argument in milliseconds. So delay of 1000, like here, would make us have a delay of 1 second. So that's what we're going to use. So when a delay is called, basically the Arduino completely stops, nothing happens for an entire second. Now we also need to make sure that we have this delay after we write low as well, because as soon as the digital write 3 low line executes, it's going to jump back up to the beginning, so we'd have the same problem. That's why we need 2 delays. Alright everyone, so now we have both built our circuit for this single LED and written our code in order to see it blink. Let's plug the Arduino in, supply some power, and see what happens. Now, as you can see, our little blue LED here is flashing on and off at regular 1-second intervals, just like expected. We did it! Now we'll move on to the next section where we make multiple LEDs start blinking.